In this video, we'll discuss the dangers of static electricity, the science of static electricity, and Motion AI's static control solutions. As enterprises get competitive, industries are adopting high-tech factory floor automation, but face product damage and contamination issues from uncontrolled static electricity. Static discharge can cause damage to electronics, ignition of flammable vapors, or injury to operators. Static attraction can cause clinging of product, adhesion of dust, and feeding or conveying issues. And static repulsion can cause scattering of parts or materials and feeding or conveying issues. So what can you do to combat static in your workplace? The first step in combating static is understanding it. So what is static electricity? Static electricity is the result of an imbalance of positive and negative charges. Objects with the same charge will repel each other, while objects with the opposite charge will attract each other. This imbalance of charges is often caused by contact between objects, and the two main causes of static charge are friction and separation. Friction charges occur when two surfaces rub against each other. In manufacturing, this can happen with conveyance and transfer, feeder bowls, and pipe and chute flow. Separation charges occur when two surfaces pull apart from one another. In manufacturing, this can happen during plastic film unrolling or roller transfer, when molding plastic goods from a die, and from opening plastic bags. Many common materials can produce positive or negative charges. Those that are higher on the spectrum, such as air or human skin, are more likely to become positively charged. The materials lower on the spectrum, like Teflon and silicon, are more likely to become negatively charged. The further two materials are from each other on the spectrum, the more likely they are to exchange electrons with each other. The potential impact one experiences from an electric shock depends on its strength. It can range from the feeling of a small pinprick to receiving a hard blow to one's entire arm. So what can you do to get static under control? You can start by adequately measuring the electrostatic charge of an object with an electrostatic meter. Once you've found a static charge, increase safety on your factory floor by combating static electricity with controlled ionizer solutions. Static ionizers emit negatively and positively charged ions, reducing static charges to low and harmless levels. Ionizers can add electrons to positively charged items, remove electrons from negatively charged items, and maintain a balanced charge once one is established. The main types of ionizers are nozzle ionizers, gun ionizers, fan ionizers, and controlled ionizers. Nozzle ionizers are used for confined or target treatment areas to lower static levels, applicable up to 3 meters from the operator workstation. Nozzle ionizers are more precise, giving you more control in directing ions to exact locations. They are also smaller than most other ionizers. They have high-frequency AC ion generation and are effective in a 20 to 500 millimeter range. You can choose from 4 different types of nozzle ionizers: energy saving for lower air consumption, high flow for longer range, female thread piping for additional attachments, and right angle for tighter spaces. Gun ionizers have various applications, including static neutralization and dust removal of resin products and electric substrates. This ionizer is ideal for any application that requires the flexibility of a hand-operated unit rather than a fixed mount one. Fan ionizers draw in and ionize ambient air using 4 electrodes located on the discharge grill perimeter. They offer many advantages, such as airflow adjustment, emitter dirt detection, detachable emitter cartridges, automatic emitter cleaning functions, optional mountable filters, functionality without the need for compressed air, and double emitter lifespans. Fan ionizers are great for stationary use, as you can simply place them in front of whatever object you need to be ionized. Controlled ionizers have separate controllers and offer 2 primary methods of applying voltage to the emitter and generating ions. In DC mode, the user can select the voltage polarity, while in AC mode, the ionizer will automatically alternate between positive and negative polarity at a selectable frequency. Dual AC mode alternates the polarity between each emitter, and the emitters alternate at a selectable frequency. Dual AC mode also allows for a mixture of positive and negative ions reaching the workpiece at the same time, reducing the potential amplitude. This feature is important for highly sensitive electronics. So as you can see, the variety of ionizers and each one's unique capabilities make for great static control solutions in an industrial environment. So don't wait. Reach out to a Motion AI expert today to start learning how we can help you with static control solutions. To learn more, visit ai.motion.com or give us a call at 1-800-AUTOMATE.